First of all, draw the region. We need to find this enclosed thing, this blob we're trying to find the area of. Y equals x squared, simple parabola. Y equals 2 minus x, line. Y equals 0, x-axis. So draw that region. Y equals x squared. Y equals 2 minus x. That is a line with a y-intercept of 2 and a slope of -1. It also means that the x-intercept, if I put 0 in for y, will be 2. That might be helpful, might not be. Y equals 0 is the other boundary of the region. Now, where's the region? What do these three things enclose? What's it? Give me a basic shape of it. Triangle. You know, a lot of students will want to say, oh, it's this. Nope, because this is not created by that blue line. So it's not that part. It is this part. And it kind of looks like a triangle, but it's not a triangle because the sides aren't straight. That red curve is not straight, so we can't do 1/2 base times height. Sorry. Now, I've drawn the region. The next thing I want to do is draw a rectangle typical to that region. And I hope I can draw just one rectangle so I won't have to have 2 integrals. You know, cut the work as much as you can. Sometimes it's unavoidable, but if I can draw one rectangle typical to that region, it cuts my work tremendously. The problem is, now don't draw this, if I draw it vertically, right there it's red minus blue. Right there it's green minus blue. That means 2 integrals. Is there another way? Yes. If I draw my rectangle horizontally, no matter where I draw that rectangle in that region, it's green minus red. That means 1 integral. So that's what we want to draw. You should draw a horizontal rectangle. A horizontal rectangle is typical to that entire region, which means 1 integration. It also means it's all about y. When your rectangles are vertical, it's all about x. When they are horizontal, it's all about y. Yes.
Does it matter which side or which line or curve you determine as the top?
Yes, it does. Good question. When you find the height of a rectangle, height is a positive measure. I mean, I might measure my height from my feet to my top of my head, but I'm not going to say I'm negative 5.5 feet 6 inches. I'm going to say top minus bottom to get positive 5 feet 6 inches. If I'm laying down, okay, let me do this. Let me do this. If I have those two numbers and I want to know the distance between them, what is the distance? What is it? 5? It's not a trick question. 5? Okay. How'd you get it? 6 minus 1. You said right minus left because the number on the right is always bigger than the one on the left. Just like if we were going from here to here, you say top minus bottom. The reason is the top is bigger than the bottom. The higher up you go, the bigger the number is. So when you're using horizontal rectangles, to find the height of the rectangle, it's right minus left. Always, always, always. Okay? Excellent question. But if it has to be in terms of y, that means you'll have to solve your equations for x. If y equals x squared, x equals the square root of y. And if y equals 2 minus x, x equals 2 minus y. So when you use the green line for the right-hand side of the rectangle, you're going to use it in terms of y. And when you use the red curve, you will use it in terms of y. So that's right minus left. The limits of integration. Since we're working with y, the limits need to be y coordinates where these things intersect. In other words, we're going from bottom to top, not from right to left. We're not going across, we're going up. So to find the points of intersection, well, this one's obvious. This one is not so. But again, you find them by setting the equations equal to each other. You want to set the square root of y equal to 2 minus y. How do you solve that? To solve any radical equation, once you have the radical isolated, you square both sides, which means on the right you have to do FOIL. You then want to get everything on one side set equal to 0 so that you can factor. So that would be 0 equals, and I'm going to rearrange to get in descending order. Whoops. And then, wait. Yes, I thought something's wrong right here. That's wrong. Thank you, Henry. That when I FOILed, I should have gotten minus 4y, and then when I bring that y over, it's a total of minus 5y. And you know what made me look at it more closely is I said, oh gosh, am I going to have to use a quadratic formula? I mean, it happens, but it's not real often. So if that, I would go back and check my work to make sure I didn't make a mistake, which I did. Thanks for finding that. Now when you factor it, y minus 4 and y minus 1, you have y equals 4 and y equals 1. And something's wrong. What am I doing? Okay, so I found that these two things intersect when y equals 4 and y equals 1. They sure do. They intersect there. They intersect here. I don't care about this one, right? Because this is the one for my region. So my upper limit has a y-coordinate of 1. My lower limit is that line y equals 0. So I'm going from 0 to 1. And then we're ready to integrate, evaluate, and go on to the next example. Do you want to take that one from there? That's right. Okay, so 5/6. So let's do one more. This one, well, I'm not giving you a hint as to how you do it. So let's draw the region. When the equations aren't solved for y, I mentioned earlier, sometimes it's harder to figure out what in the world the graph is. So you can always plot points. But, you know, if you have y equals x squared, we know it's a parabola. If it's x equals y squared, it's also a parabola. But when y is a squared variable, it's a right or left thing, whereas when x is a squared variable, it's an up or down thing. So let's draw it, see what happens. 2y squared equals x plus 4. Let's see what the x-intercept is by putting 0 in for y. So x will be -4. Let's find the y-intercept by putting 0 in for x. If I put 0 in for x, 2y squared equals 4. Y squared equals 2. So I get y is plus or minus the square root of 2. Well, the square root of 2 is about 1.4, so it's going to cross there and there. You can plot more points if you need to, but the basic shape should be a parabola. This one opens to the right. The coefficient of the squared variable is positive, so it opens in a positive direction. Y squared equals x. Well, intercepts don't get me very far on this one. If I put 0 in for x, I get 0. If I put 0 in for y, I get 0. So now what? So pick something else. Put 1 in for x. Y squared equals 1. Well, if y squared equals 1, y equals plus or minus the square root of 1. So when x is 1, y is 1, or -1. So there's that parabola. Whoops. Also opening in a positive direction, because the coefficient of the squared term is positive. So there's the blob. We want the area of this like boomerang type thing. So once I have it drawn, I try to draw a rectangle typical to the entire region. So I'm thinking about it If I go vertical, which would be my preference, that's going to give me 3 integrals. Don't draw this. But you'd have red minus red, red minus blue, blue minus red. 3 integrals? Ugh. So let's see if we go horizontal. Up here, blue minus red. Blue minus red. Anywhere I draw it, blue minus red. I like it. So the height of my typical rectangle is blue minus red, right minus left. It's horizontal. It's all about y. So my equations have to be solved for x. This one already is. This one I need to bring the 4 across. So tell me right minus left. What do I put here? Excellent. And then I need to know the y coordinate of where these things intersect. So I can get that by setting the equations equal to each other and solving for y. So I would have y squared equals 2y squared minus 4, which means that y squared equals 4, or y equals plus or minus 2. So the y coordinate here is negative 2. The y coordinate there is positive 2. Question? Okay. So I'd simplify here, distributing the negative. Y squared minus 2y squared is negative y squared. Minus negative 4 is plus 4. So we can do that and work it out and get our answer. Let me suggest even a simpler way. Do you see any symmetry in this figure? Yes. Do you think that the area of this part up here, how does it compare to the area of this part down here? They're the same. You know what you can do when that happens is you can find the area of one piece and double it. So you could do that. Yes, you could change your lower limit to 0, leaving your upper limit 2, and double your answer. Don't you love it when your lower limit is 0? I mean, it doesn't always end up being 0, but it sure simplifies things. So I'd like you to finish that. Either way you want to, you should get 32/3. Anytime your region has symmetry, you can do that. And I think this is the first one we've run across that did today. But you'll see it happening in others.